Alright, in section 2, we're discussing means, but there's a couple of different ways you would do means. One would be for a matched pair, and so they are dependent. One value depends on the other value, what you're comparing it to. And the other ones, those are independent, and that's something we'll be doing in the next section. So, the accompanying data represents the muzzle velocity in feet per second of rounds fired from a specific gun. For each round, two measurements of the velocity are recorded using two different measuring devices, with the accompanying data obtained. So, why are these matched paired data? Well, they are using two different measuring devices, but they come from the same gun. So we have something that's coming from the same gun, so that's something that it's dependent upon. One bullet from this gun measured with a device, and then another bullet from this gun measured from a different device. And so A seems like a good... They come... So, sorry, two measurements A and B are taken on the same round. So you shoot a bullet, you measure it with this device, and you measure it with the second device. So they're matched paired. And then we're going to have to make our hypothesis statement. Again, the mean difference, again, that's something that should always equal 0. Similar to how we did with proportions. It was either P1 equals P2, basically saying that the difference was equal to 0. And then we have to conclude from up here what the alternative hypothesis is. Is there a difference in the measurement of the muzzle velocity between device A and B? So is there a difference? That would be a not equal to. So I'm liking choice C. So the mean difference is equal to 0, saying that the mean of both the devices are the same, and then it says, is there a difference, which means that they're not equal to. P-value. Well, now we need the data. And so if we look, here we have the data. Let's bring it over to StatCrunch. Alright, so we have A and B. These are our data. So now if we go to a test statistics, we have, instead of two sample, we'll use that in the next section, we're dealing with paired data. Paired data. And so sample 1 is in A, sample 2 is in B, and this is our hypothesis test. If we want to save the differences, maybe you'll have a different question that asks you some information. We can do that, click Save Differences, but now let's compute. Oops. B. So if we do that, notice they put the differences, so this is just doing A minus B, gives us our differences. But we have a test statistic, we have a p-value, everything that we need. Notice that our degrees of freedom, since we have 12 different observations, is just one less than that. So now we can come down here and put in the p-value. To 3 decimal places is 0.531, and that's a pretty big p-value, right? So if the p is bigger, we would not reject. P is low, ho gotta go, but if it's too big, I guess the ho sticks around. So we do not reject the null hypothesis. There is not sufficient evidence that there's a difference in the measurements of velocity between device A and B. Still got 3 parts remaining. So a 99% confidence interval, we can do that pretty easily. So instead of doing a hypothesis test, let's do a confidence interval. And they said a 99. Let's compute. So here's our lower limit. 348. And our upper limit, which is 0.532. Again, since 0 is within this interval, we're kind of saying that, we believe that 0 is in between that value, so we think the mean difference could be 0. The population mean could be 0. We are 99% confident that the mean difference in measurement is one of the differences in the data set. Is between the two values. The mean sample difference or the mean difference. So we have a couple things that seem similar. For a random firing, we are 99% confident that the mean difference in measurement is between these two values. So we're going to go with D. It's not the sample difference. We think that the mean difference. Sorry, my phone's blowing up. Let's check that. A couple more questions on this one. So draw a box plot of the difference. Well, if we want to do a box plot of the difference, we can do that. Here's our differences. Let's do a graph, box plot of the differences. I don't know why it has two of them. Let's do that one. And there we go. And we can make it look similar to what they have horizontally. Alright, so kind of looking at them. Looks more like so the mean's above 0, or the median is. Oh, this one's a little tricky, isn't it? So it goes up to 0.9, goes down to negative 0.7. So it's not that one. This one's kind of looking good, except for where the median's at. So I don't like that one. That one does go down to negative 0.7, so it's not this one. What's our median? 0.2. This one looks good. Just comparing the features. Let's go with that one. Good. One part remaining. Does the visual evidence supports the result obtained in B? Well, if we think that in B, we said do not reject the null because we think 0 is in there. Is 0 in that interval, right? We think 0 is pretty close. So yes, we do think that. Let's look at one more, just the outline of it, make sure it's similar. We have data, right, from impaired and normal. So from this, we're going to do the exact same thing. We would be looking at, let's see why it's a matched paired. Student reaction time in an emergency was measured with unimpaired vision and also while wearing a pair of special goggles to stimulate the effects of alcohol. So it's the same person, this data, right? So here's the reaction times, normal, and then with the beer goggles, right? Normal beer goggles. So we're looking at the differences to see if there truly is a difference. Is it really the same, so the difference is 0, or is there a difference? I just want to look at the data real quick. I'll let you go back and answer the questions. But if we're doing a t-stat, right, we're comparing means, paired means, because it's the same person. We have one normal, and then the other one and paired, sure, we can save the differences. And let's just put that they're not equal to each other. On this one, it says like the p-value is super low, right? Saying that there is a difference. We would reject the null, saying that the difference is equal to 0, right? We do not think that the means are the same. We think they're different. So we'd go with the alternative. Really big test statistic also implies that. So again, we're just taking the data. It's a matched pair because it's the same student, and that should get you started on this problem.